Hi guys, good evening. Hi guys. Yes, good evening. Yes, can you hear me? Yes, am I audible? Yes, can you hear me? Yes, am I audible? Yes, okay. Yeah, yes, 1 second. If anyone, yes, unable to hear me, if anyone unable to hear me, yes, please rejoin. If anyone unable to hear me, please rejoin into session. Rejoin into session. Okay. If anyone unable to hear me, rejoin session. Okay. Presently, yes. Presently, yes. I'm speaking. Yes, I'm speaking. Presently, I'm speaking. Okay. Presently, I'm speaking. Yes. If anyone unable to hear me, please rejoin. Yes, I'm speaking here. Yes, I'm here. Presently, I'm speaking. Okay. Anyone unable to hear me, please rejoin. I think almost everyone able to hear me. Yes, everyone. Yes, except one or two guys, almost everyone able to hear me. Yes. Okay, fine. Please rejoin. If anyone unable to hear me, please rejoin into session. Presently, I'm speaking. Okay. Yes, starting session. Yes, starting session. Starting session. Okay. Yeah. Let us start session here. Yes, still again I'm saying that if anyone unable to hear me, please rejoin starting your session. Okay. Yes, if anyone unable to hear me, please rejoin. Please just rejoin. Just rejoin. Just enough. Okay, just rejoin. Yes, rejoin. Yes, Nilesh. Please rejoin into session. Just rejoin. Just rejoin. Rejoin into session. Rejoin. Yes, rejoin is solution simply here. Just rejoin. Anyone unable to hear me, please just rejoin. Okay, fine. Now let us start session. Yes, let us start session here. Yes, so Java. Okay, yes, Java. Actually, our syllabus is core Java. Yes, Java. Let us start Java here. Yes, yesterday just introduction about myself. Next, course contents, duration, all that topic explains about course contents, course plan, everything clearly explained yesterday. Yes, today we'll start Java. Okay, Java. Exactly what is Java? Okay, exactly what is Java? Generally, here anyone says that it's an object-oriented programming language. What is Java? It's a OOPS language. Simple answer is what is Java? First question is what is Java means? What is Java? First question, what is Java? What is Java? Yes, simply anyone says that yes, it is objects. Yes, objects, oriented, objects. Yes, oriented. Yes, the objects oriented programming language. Anyone simple answer. Anyone says that object oriented programming language. Okay, objects. Yes, oriented programming language. Okay, objects oriented programming language here. Okay, simply anyone says that. So what is Java means? Yes, it is an object-oriented programming language. That's okay, fine. That's simple answer. Yes, various kind of things are there. We should discuss many things about Java here. Yes, let us see one by one here. Okay, what is Java? Next, what are the features of Java? What are the different editions of Java? What complete Java? What is complete Java? Complete Java. Yes, complete Java. See, complete Java. Yes, complete Java. See, complete Java contains what? Okay, so what does contain complete Java care? So what does, yes, what does contain Yes, complete Java. Okay. Yes, complete Java. What does it contain? Simply question here. Complete Java. Complete Java. What does it contain? Question is, what does it contain here? What does it contain? Complete Java. What does it contain? That is the topic we'll discuss. Next, one more thing here. Why Java got this much of popularity? Why? Yes, next question. Why Java has this much of popularity? Why Java has this much of popularity here? This is one more question here. Why Java has got this much of popularity? So what's the reason here? Next, one more question this is. Okay, first question, what is Java? Next, complete Java. What does it contain here? Next, why Java has this much of popularity? These are all things we'll discuss. Okay, now let us start. Here, see, first version of Java. First version of Java. First version of Java. Next, one more thing, why named as Java, that also we'll discuss. Why named as Java? Why named as Java, that history also will discuss. That history also I'll explain. Wait. History also will discuss. First version of Java was released. Released, yes, in the year 1995. First version of Java was released in the year 1995. 1995. Okay. Yes, 1995. That time I was in engineering second year. Yes, I was in engineering second year. In engineering second, computer science, engineering second year. That time, yes, I was in the year second year. Okay, engineering second year. I was in engineering second year. That time, yes, Java was released. First version of Java was released in the year 1995. So first version is JDK 1.0. So JDK 1.0. JDK stands for Java, yes, development. Java development kit. Java development kit. Java development kit. JDK 1.0. Okay. Yes, the JDK 1.0 released with some primary features. Yes, JDK 1.0, JDK 1.0 released with yes, primary features. Released with primary features. Okay, primary features as below. So what are the primary features of Java here? JDK 1.0 released with main features. Okay, main features. Okay, JDK 1.0 released with main features as below. 41. Yes, what are the main features of Java? Okay, so main features of Java, Java main features. So main features of Java. So what are the main features of Java? 41. Yes, independent of platform. Independent of platform. Okay, what are the main features of Java? See, JDK 1.0 released with main features as below here. Main features. So what are the main features of Java here? What are the main features? Main features of Java. Main features of Java. First one is independent of platform. Okay. Yes. Independent of platform. Still many are unable. Yeah. Okay. I hope everyone able to hear me. Yes. Right. Everyone is okay. Fine. Except maybe some Hemant or somebody. Okay. See, still, if anyone unable to hear me, please rejoin. Yes. If anyone unable to hear me, please rejoin. Yes. Once again, I'm saying this is. If anyone unable to hear me, just rejoin. If anyone unable to hear me, please rejoin. Okay. Please rejoin. Yes. So first version of Java was released in year 1995. Okay. That time I was in engineering second year. Computer science, BTech computer science. Okay, JDK 1.0 first version, JDK 1.0 first version, Java development kits. Okay, Java development kit here, development kits. Okay, JDK 1.0 released with main features as well. So what are the main features of Java here? Yes, independent of platform. Yes, we'll discuss what is independent of platform. Yes, we should discuss many things in this independent platform. Okay. Yes, independent platform. Next, yes, portable. Java application, portable application. Portability. So portable. Next is portability. So first one is independent platform. Next one is portability. Java application is portable. Yes, how it is portable, we'll discuss next. Wait. Okay, independent platform. Next, portability. Yes, next. Java is an object-oriented programming language. OOPS language. Yes, it's OOP language here. Object-oriented programming language. Java is an object-oriented programming language. Like a C++. Like a C++, Java released with OOPS concept. Okay. Yes, Java released as a OOPS object-oriented programming language here. Java released as a object-oriented programming language here. Java released as a object-oriented programming language. Okay, right? Yes. Next, scalability. 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 What is scalability? I will explain. Just wait. Yes. Let me list out all the main features. Later we'll see one by one here. So next one here. Yes. Security. Security. Okay. So these are the main features. These are the main features. Okay. So main features of Java. Yes, independent platform. Yes, JDK 1.0. JDK 1.0 released with these features. Released with these features here. Independent platform. Next, portability. Next, object-oriented programming language here. Next, scalability, security. Yes, we'll see one by one. Wait, I'll explain. I'll explain very clearly. Okay. It's not 5 or 10 minutes topic here. Yes, this is minimum 1 hour topic, independent platform. I should explain very clearly. So this is 1.0. Okay, right? Next after this, JDK 1.1. Okay, JDK 1.1. So this version. So JDK 1.1 is divided into 3 editions. Divided into 3 editions. Okay, JDK 1.1. Yes, 1.0 released with all the main features here. After that, next 1.1, JDK 1.1. Say JDK 1.0 in the year 1995. 1995, year 1995. So JDK 1.1 in the year 1996. 1996. Released in the year 1996. JDK 1.1, 1996, divided into 3 editions. 3 editions. First one is here. Java Standard Edition, JSE. Okay. Yes. Old version. Yes, we used to call as JTSE. JTSE. Okay. So Java Standard, Java Standard, Java Standard Edition, Java Standard Edition. Yes. Java Standard, SE called as Standard Edition. SE called as Standard Edition. SE called as Standard Edition. Okay. Next. Yes, JW. Yes. In old version, yes, called as J2W. J2W. Now it's calling as JSE. JSE, JW. Old version we used to call as JTSE. JTSE. Next J2W. J2W. Okay. So what is J2W here? Java Enterprise. Java Enterprise Edition. Java Enterprise Edition here. Enterprise Edition. Java Enterprise Edition here. So W means Enterprise Edition. It's an Enterprise Edition. Enterprise Edition. Enterprise Edition. Enterprise Edition. Okay. Next ME. Yes, JTME. Yes, in old version called as JTME. JTME. Okay. Yes, previously before 2010. Before 2010 called as JTSE, J2W, JTME. Now it is calling as Java SE here, Java Enterprise, Java Mobile Edition here, Java. So next one is Java Mobile Edition, Java Mobile Edition here, Java Mobile Edition. Okay, right? So this is JDK 1.1. Okay, JDK 1.1 here. Yes, what are the SE features? We'll see. First of all, we'll see about primary features. After finishing all the primary features, we'll go to SE features, next enterprise features, next ME features. Okay, right? Yes, this is JDK 1.1. Okay. Next, JDK 1.2, 1.3, 1.4, next JDK 1.5. So next 1.5, yes. Yes, 1.5 is a year in there, 2004. Yes, it's a Tiger version. Tiger version. It's a Tiger version. Major changes in Tiger version here. In Tiger version, major changes. Tiger version. Yes, major changes done. Major changes. Major changes. Okay. Major changes done with Java software. So JDK 1.1. Okay. After this, next JDK 1.2. Next JDK 1.3. Yes, next JDK 1.3. Next JDK 1.4. 1.4 like this. Next is, so first JDK 1.0 released with main features of Java. Next JDK 1 in 1.1, JDK 1.1 here divided into 3 editions like SE, Enterprise and Mobile Edition. Next later JDK 1.2, 1.3, 1.4, next 1.5, JDK 1.5 2004 Tiger version. Major changes were done. Here major changes were done. Okay. Yes, in JDK 1.5. Yes, one more. Yes, one more edition. One more edition added. One more edition added. One more edition added. Okay. Yes. Yes. One more edition added called the edition called, yes, Java FX. FX called Java FX here. One more edition added FX. FX. So fourth edition here. Fourth one. JFX. JFX. Okay. Yes, JFX. Yes, means Java. Yes, Java. Yes, Java effects here. Effects. 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 Simply calling as effects, but actual name is effects. Java effects. Java effects. So finally here, finally, yes, Java. Yes, Java divided into divided into 4 editions. Finally 4 editions. Finally 4 editions here. So first see, yes, finally here. Next fourth one is FX. That's it. This is current Java, latest Java. Okay, latest Java contains 4 editions. There are 4 editions in Java. Finally, Java divided into 4 editions. There are 4 editions in Java. Java SE, next Enterprise, next Mobilization, then FX. These things. Okay. Yes. Next, we should discuss about what are the SE features, what are the Enterprise features, yes, ME features, and FX features. We'll see one by one. Before that, let us start with these main features. Yes, today topic is about main features of Java. Main features of Java. Main features. Main features. In main features here, first topic is independent platform. Yes, independent platform. Yes, how Java is made as independent platform. What is platform? Yes, independent platform. What does it mean? What does it mean here? Platform means OS. Platform means is nothing but say is a combination of hardware and software. Platform means yes, it is a, yes, a combination of hardware, yes, hardware and OS. Hardware and OS. Yes, I'll explain this. Platform means it's a combination of hardware and OS. Hardware means like maybe 32-bit processor or 64-bit processor. Yes, 30-bit or 64-bit. 30-bit or 64-bit here. 30-bit or 64-bit. This platform means it's a combination of hardware and OS. Hardware and OS. Yes, we'll see. Yes, exactly what is platform? Yes, let me explain that. Yes, Word document. Yes. First, for this purpose, yes, you need to have the idea about OS. Platform means is a OS here. So what is OS, how it's working, that you have to understand. If you understand OS, then easy to understand independent platform. Okay, to understand independent platform, first of all, OS behavior you have to understand. So once you understand OS behavior, yes, once you understand OS behavior, then you can understand independent platform. Now, first of all, let us see what is OS. What is OS? What is, first question is what is OS? What is OS? Independent platform. Platform means is OS, right? What is OS? 1 second. Before going to this one here, one more question here. One more question for you guys. Yes, one question for you guys. Yes. Can we run any program without OS? Say yes or no. This is question for you. Can we run any program without OS? Can we run any program without OS? Say yes or no. Can we run any program without OS? Say yes or no. Just ping in chat box.
No, no.
The chat box, right? Just ping me in chat box. I can see. You can speak also, no problem. You can speak or else you can ping in chat box. Can we run? Question is, can we run any program without OS? See, 1 second. In every topic, I'll cover some interview kind of questions for freshers. In every topic, we'll be discussing that questions, that kind of questions. Yes, it's the interactive session. Okay, it's not one way, it's interactive session. Interactive session. Now, question is, can we run any program without OS? Yes, question
No,
is
no.
no. Answer is no. Right, you are right. Okay, answer is no. Answer is no. Chat box. Just ping in chat box. Answer is no. Can we run any program without OS? Answer is no. Answer is no. Okay. Now, first let us see what is OS. What is OS? What is OS here? What is OS? Yes. Operating system. Okay, fine. Good. Well and good.
Yeah.
So, okay, fine. So, what is OS? Let us see what is exactly OS. Yes, sir. Yes, to understand independent platform, some idea about OS. OS behavior. If you know that OS behavior, then you can understand first one, independent platform. To understand independent platform, you must have OS behavior. If you have the OS understanding, then easy to understand this independent platform. Let us see what is OS. See, suppose your computer, your laptop, yes, hardware, your laptop hardware. On top of this, installing OS. Suppose when you purchased your laptop here, when you purchase laptop, first purchasing laptop, after purchasing laptop, on top of it, operating system running. Okay, first purchasing your laptop, after purchasing laptop, next you have to install OS. Once OS install, your system is ready. Now this is my system with OS. Now it's a OS refresh. It's a Windows OS, right? It's a Windows OS. My system is ready with OS. My system is ready with OS, right? Suppose learning Java. Next you have to install Java. Suppose learning C language. We should install C language. Learning C++. Yes, you have to install it. Suppose learning Hadoop. You have to install it. So learning a database that should be installed. Yes, all these are application softwares. All these are called as application softwares. Application softwares. Yes, all they are called as application software. Okay. Yes, application software. Java, C, C++, Hadoop, database. Yes, maybe Python. Yes, maybe Python. Like this. All these are application softwares. Okay, right? Yes. On top of which, all the application softwares running here. Without OS, these programs cannot run here. Maybe Java program, C++ or C or Hadoop, Python. To run all the programs, OS required. Without OS, these cannot run. That means on top of OS, all are running. On top of OS here, all are running here. Even MS Office also. For example, MS Office. Even for MS Office, also OS required. For MS Office also OS required. Without OS, these cannot run. So on top of OS, all are running. All are running on top of OS. Okay, means now OS giving platform. So OS is giving platform for the applications, right? See hardware, on top of hardware, there's a OS. This whole thing is not a platform. It's a platform. This whole thing is called as platform. Okay, hardware layer, yes, then OS layer. Yeah, these two layers is nothing but these two layers is a platform. 1 second, sorry. 1 second. Yes. So these two layers is nothing but a platform. So here this is Waze. So Waze is acting like a platform to run all the application softwares. So what is Waze? Question is here, what is Waze? So what is Waze? What is Waze? First point. What is Waze? Yes, it's a platform. Simply it's a platform. Okay. Now question is here, Java is independent of platform. First of all, what is platform? What is platform? We should know about platform. First, we'll see about platform. After that, we'll go to the Java. We'll go to Java. Okay. Yes. What is Waze? Waze, it's a platform. So Waze is a platform. It's a platform. It's a platform. Waze is acting like a platform. It's a platform where we can run all applications. Yeah, tell me.
application service.
Yes, where we can run all application softwares. It's a platform. Okay, simple. Yes, anyone asking an interview here. As a fresher, you have to face this kind of interviews. Interview questions here. What is Waze? Simple answer. It's a platform. Waze is a platform where we can run all application softwares. All application softwares. Okay. Yeah, these all are application software programs. Java running on top of OS means OS is a platform. For Java, OS is a platform. For C program, OS is a platform. The C++ for all the programs, OS is a platform. So it's a platform where we can run all the application softwares. It's a platform, right? Not only platform here, not only platform. Suppose, for example, here, Java program generating some output here. That output first of all goes to OS and then transferred to output device. Okay. So for reading from the keyboards, first the keyboard data goes to OS to then Java program. Yes, similarly C program. So C program output goes to OS to output device. So reading from the keyboard data goes to OS to this program. So between softwares, all these programs and the hardware, there is a OS. It's a middle layer. It's a middle layer between these two here, like interface, mediator, interface. So OS, yes, it is an interface. It is an interface. It is an interface. It's an interface between. It's an interface between yes application. Yes application. Yes softwares. Application software. Hardware components. Hardware components. Hardware components. Yes, everyone you must get this point, this idea here. Then you can understand Java here. Okay, it's a platform where we can run all the application software. Next, it's an interface. It's an interface between application software and hardware components. Okay, see here Java program or C program or Hadoop. Yes, database something like this. Yes, all these programs communicates with the hardware through the OS. For this communication purpose, every OS has its own input output library. They say input output library. Input output library. See why I am explaining all of the things. Reason to understand independent platform, you must have this knowledge. If you know this OS architecture, then you can understand independent platform. Generally, any trainer says that independent platform means independent OS. Simple, that's it. Matter of 5 minutes, they will explain. After they will go to next topic. But my way is not like that. Including internal like that. Including internals. Including internals. Okay. Now here, operating system kind of input output library. Okay. See every program, maybe Java program or C program or C++, Hadoop or Python, all programs, all application software programs communicates with the hardware through the OS library. Compulsory OS library requires. Okay. So every program communicates. Remember this point. This point is very, very important for Java understanding here. Yes, every program communicates with hardware, communicates with the hardware yes through the OS library, here, OS library. So without OS library cannot communicate. Compulsory OS library required here. Okay, Every program communicates with the hardware through the OS library. Now Java communicates with the hardware through the OS library. Okay, so here at runtime here, OS library links to Java program, then communicating the hardware. Similarly here, C. So OS library communicates with the C application, yeah, then communicates hardware here. This input output library has to link with Java or C program or C++ or Hadoop, Python. Okay, so OS library has to link with your program to communicate with hardware. Yes, when that linking takes place, you see that. Suppose C language, yes, C and C++ may be static link. Java means dynamic link. Python is a dynamic link. Yes, with Java it's a dynamic link. Python also dynamic link. But C and C plus static link. Yes, we'll discuss. Wait, I'll explain the topic very clearly. Very clearly we'll discuss. Very clearly we'll discuss that. Okay. So this is OS. Just idea about OS. So what is OS? It's a platform where we can run all the application software. It's a platform. It's a platform where we can run all the application software. It's an interface between application software and hardware components. Interface between application software and hardware components. Next, every program. Remember third point. Third point is most important. Third point is most important. Every program communicates with hardware through the OS library. Compulsory OS library required here. Yes, every program has to communicate with hardware through the OS library. That OS library has to link with your program, otherwise never communicates. Compulsory OS library required. For every program, OS library required. Okay, fine. Fine, well and good. This is OS introduction. Okay, now let us come to our point. What is our point? Java is independent platform. Java is independent platform. Now question is here. Platform is simply a OS. It's a combination of hardware and OS, right? This layers is two layers is nothing but a platform. These two layers is a platform. Okay, two layers is a platform. Hardware and OS. Hardware and OS. It's a platform. It's a platform. On top of it, all the programs running, right? Now Java is independent of OS and hardware. That means, okay.
Yes.
Java is the independent of, yes, Java is independent of platform means, yes, independent of platform means, yes, it's a independent of, yes, independent of platform. Independent of platform means, yes, it's a independent of, yes, it's a independent of, it's independent of OS and hardware. OS and hardware. OS and hardware. Is like that here. So independent of platform means it's a independent of OS and hardware. Okay. See, platform means it's a combination of hardware and OS. Okay, now here independent of platform. Independent of platform means it's a combination. Yes, it's an independent of OS and hardware. Okay. Yes. 1 second. I will mute all of the guys. Don't worry. Yes, muted. Muted everyone. Okay. Yes. It's an independent of OS and hardware. It's independent of OS and hardware. No question is here. Okay, this point everyone says Java is independent of platform, it's independent of OS and hardware. This point generally anyone says. That's like a fine. Fine. Now question is how Java made us independent of platform. Made us independent of platform. Independent of platform. That is question. Okay. How Java made us independent platform? This question. Yes, how to answer this question? How Java made us independent platform? Yes, to answer this question here, yes, you should know about some terminology like yes, what is interpreter? What is interpreter? Okay, next. So next, to understand that point here, yes, how Java made us independent platform? To understand this question here, to understand this topic here, you must have this. Yes, you must have this knowledge. What is interpreter? First question. Next, second question. Yes, what is compiler? What is compiler? What is compiler? Okay, right. Next, third one. What is exe file? These points. What is exe file? If you know these points, you can understand independent platform. How Java made us independent platform. Okay. So what is platform? That is clear. What is platform means? Independent of platform. What is platform? Platform means that platform, this is clear. These two layers is a platform. That point is clear. Okay. Yes. So what is platform means? These two layers is a platform. It's a combination of hardware and OS. Combination of hardware and OS. It's a platform. That point is clear. What is platform? That point is clear. Okay. Next question is how Java made us independent of platform? Yes, we should answer this question here. Yes, to understand this one here, first of all, what is interpreter? What is compiler? What is exe file? If you know about these things, then you can understand this one. Now, let us go to this. What is interpreter? What is compiler? Let us see about interpreter and compiler. So what is next? We'll see about exe file. Okay. So interpreter and compiler. Okay, right? Yes. Tell me what is your idea about interpreter and compiler? Yes, interpreter and compiler. Interpreter versus compiler. Yes, interpreter. Yes, interpreter. Yes, versus compiler. Our topic now here. Interpreter versus compiler. Okay. Yes, interpreter versus compiler. Anyone? I'm here to explain everything. Don't worry. I'm here to explain everything. But just I'm asking your idea. Just simply I'm asking about your idea. What is interpreter? What is compiler? Yeah, generally who complete engineering may be having some idea, some little bit idea. Generally in your college, maybe learning interpreters line by line compiles whole program. General simple points. Yes, anyone in your college level may be learning this point here. Yes, anyone in your college, in your engineering level may be learning just one point. Interpreters line by line compiles whole program at a time. This point learning. Okay, I'll tell you exactly what is interpreter, what is compiler. Yes, what is interpreter, what is compiler? Let us see about this. Okay. Yes, interpreter and compiler. Okay. See, interpreter and compiler. See, interpreter and compiler. Okay. Yes, interpreter. Yes, interpreter and compiler. Interpreter, compiler. Compiler, both converts your program codes. Nothing but it's a high level language. Yes, high level language. Your code means high level language. Yes, your program codes. Nothing but source code. It's a high level language here. Yes, your program code means is source codes. What are the program you are writing here? The source code, right? Source code means high level language. See, languages. Yes, in software language, basically two categories: high level language and low level language. High level and low level language. High level, yes, high level, yes, high level languages. Next, second one, low level languages. High level language and low level language. High level, next low level. Yes, low level languages. High level and low level languages. Okay. Yes, high level and low level languages. Okay. Yes, low level languages. Yes, next high level languages. See, low level languages. Yes, these are system understandable language. Yes, it is a system understandable language. A system understandable language. System understandable. It's a system understandable language. 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 So you can low level language means it's a system understandable language in the form of binary code. This is in the form of binary code. In the form of binary code, right? Like zeros, ones, like this. Zeros, ones. In the form of binary code. It's a system understandable language. Okay. Yes, called as machine language. Machine language. It's a machine language. It's a machine language. Okay. Yes. So you get low level language. It's a system understandable language. In the form of binary code. It is in the form of binary code like zeros, ones. Yes, called as machine language. It is called as machine language. Okay. Next, what is high level language? High level language, it's a user understandable language. User understandable. User understandable language. User understandable language. User understandable language here. User understandable language. User understandable language. User understandable language. Right? Okay. User understandable language. Yes. High level language. User understandable language. Right? Yes. This is like English language. Like English language. Very easy to understand. Like English language. Like English language. Like English language. This is like a yes English language. Like English language. Yes, very easy to understand. Very easy. Yes, very easy to understand. This is very easy to understand, right? Very easy to understand. Yes, high level languages. Every language except machine language. Except machine language, every language comes under high level language here. Example, high level language examples. C, yes, C++, Java, okay, yes, next Python, okay, yes, maybe Perl scripting, yes, next HTML, okay, next maybe Python, okay, Python, yes, .NET C hash, yes, all these high level languages, all these are high level languages, okay, yes, high level language, there looks like English language, C language, C++, Java, Python, Perl, HTML, all these are high level languages. All these are high level languages. Okay, 1 second. About these notes, you don't worry. I have prepared very clear documents. Yes, Java documents. Let me open documents. See Java documents. Yes, in documents from the very beginning, it was explained here. Explained very clearly. Okay, after explaining all of this, started Java. Okay, see that introduction. Yeah, I'll share this document. Don't worry, I'll share it. Okay, I'm creating WhatsApp group. After creating WhatsApp group, I'll share this one here. Okay, yes, I'll take your email IDs. I will take email IDs from the online team. I'll share it. Okay, I'll take your email ID. Don't worry, I'll share it. See, introduction to software. Software is a collection of programs like C, C++, Java, something like this. In software, basically two categories: system software, next application software. Yes, just like a beginning, this is okay. Just like a beginning, starting like a beginning here. Anyone can understand this one here. Like a beginner, it's a beginner. Yes, even non-native background, they also can understand this point here. Yes, software, it's a collection of programs like C, C++, Java, something like this. Software basically two categories: system software, next application software. System software, this one interact with hardware components, interacting with hardware components like device drivers and operations. This is not our part. Our part is application software. See, software basically two categories. Software basically two categories. Two categories. First one system software. Next one is application software. Next here system software interacting with hardware components. Interacting with hardware components. Device drivers and OS comes under this category here. But this is not our part. Our part is application software. Yes, application software for the purpose of application development. For the purpose of application. Yes, application may be Facebook application, maybe Facebook application, maybe Gmail application, maybe some company websites, maybe Flipkart. To develop such kind of applications, we need application softwares like C, C++, Java, .NET, Python, these things here. So Java comes in what? Application software. Java is a application software. Now let us move to application software. Yes, our topic is application software. Yes, application software basically two categories. Application software again two categories here. There's a front end and back end software. Front end, back end here. So back end is to store data like databases and files. Back end to store data, store and maintaining data. Databases and files comes in this category. Okay, right? Next front end interacting with users. Java comes under front end here. Suppose Oracle database comes on back end here. Java comes under this one here, like language and packages. Java is a language. Languages and packages comes in the front end here, front end. Next in front end, basically two categories, languages and packages. Package is a ready-made one. Package is ready-made one, like MS Office is a package. Okay, package ready-made one, ready to use. Language, we should write the coding. Okay, Java comes under languages. Now let us move to languages. Yes, in languages, low-level languages and high-level languages. Okay, low-level and high-level language. Low-level, these are system understandable languages. Yes, machine language. Machine language. Yes, high-level language. These are user understandable language, like English language. Okay, so this is introduction. How I'm introducing here. See, started from very basics. What software? What is software? First point is what is software? Software is a collection of programs such as C, C++, Java, SQL, Python, something, all this. Next, software basically two categories: system software, application software. So Java comes under application software. Java is the application software. That's the reason move to application software. Yes, moving to application software. Application software basically two categories. There's a front end, back end. Java comes under front end. So that's the reason moving to front end. In front end, languages and packages. Java comes under languages. So move to languages. In languages, low level and high level language. Java comes under high level language. Java comes under high level languages. Okay, fine. Next, when come to languages here, there are some generation of language. First generation, second generation, third and fourth. There are four generations totally here. First generation, second generation, third generation, fourth generation. Okay. First and second generation comes in low level languages. Yes, machine language, assembly language. These are system understandable languages. These are system understandable languages. Low level languages. Next, high level. These are user understandable languages. Like third generation, fourth generation. Third generation, procedure oriented language. Fourth generation, functional oriented, object oriented, and object based. Functional oriented, C is a functional oriented language. Object oriented, C++, Java, Python, object oriented. Object based, JavaScript. Okay, so these are just basics. Okay, the basics only here. Okay, now our topic is high level language and low level language, right? High level and low level here. High level language. So every high level language code has to convert into low level language, system understandable language. Who will do that here? Who will convert it here? Who will convert? Who will convert from high level language to low level language? Either compiler or interpreter. Now these are our topic here. Interpreter and compiler both converts. Both converts your program code, means high level codes, into system understandable language. So into both converts. Okay, into system understandable language, system understandable language, system understandable language here, system understandable language. Okay, system understandable language. Okay, yes, interpreter and compiler both converts your program, means your source codes into system understandable language. Yes, source code, that code, high level language program, maybe C program, maybe Java program, something like this. 1 second. Source code means what are the program you writing, that is called source codes. 1 second. Let me show one example here. Yeah, this is called a source, this program. Here some program is there here. Some example here. See, this is. Yeah, this is some example. This program is called high level language, right? Looking like English language. Yeah, this code is source code. What are the program you're writing? C program, Java program, all the programs called source code. It's a source code, this source code. Now this is high level language. This high level language. System can't understand this language, right? What is system understandable language? Machine language. Now this code has to convert into machine language, then executing. This code has to convert into binary code, then executing here. Who will do the task here? Who will do that here? Yes, either compiler or interpreter. So compilers, interpreters and compilers. Interpreter and compiler both converts your program code, means source code, high level language, into system understandable language. Okay. So interpreter compiler both converts high level language to system understandable language, means binary codes. But there is a difference. Both are doing same job, but there is a difference. Okay. So interpreter compiler, both are doing same job. What is the job here? High level language means your source code to binary code. High level language to binary code. Both are converting into binary codes and giving results. But the way it's working is different here. Interpreter working is different, compiler working is different here. Now let us see interpreter versus compiler here. Interpreter versus compiler. Interpreter versus compiler here. Yeah, this is most important question. Yes, can you differentiate interpreter and compiler? Yes, can you explain interpreter versus compiler? Maybe asking this question. It's a fresher question. Freshers getting interpreter versus compiler. What is exact interpreter and compiler? Let us see. Interpreter versus compiler. Yes, let us start with interpreter. First, let us start with interpreter. So what is interpreter? How it's working here? Interpreter. Yes, interpreter. How interpreter is working? About interpreter. Okay. Yes, interpreter working on your source code. Interpreter working on your source code. That source code may be some HTML scripting, maybe Python scripting, maybe Linux shell scripting. Okay, interpreter works on scripting languages. That point we'll discuss. Wait. Interpreter always working on scripting languages. Okay, compiler working on programming languages. That point we'll discuss next. Wait for some time. Now interpreter. How interpreter is working? Let us say about interpreter. Suppose let us take some program statements. Suppose, for example, here this is your program. For example, how interpreter working on your program. Okay, suppose your source codes, some statements. Suppose first statement here, first statement. Okay, yes, next statement. Yes, next statement. Okay, next statement. Okay, next statement. So like this, some statements here. Your program statements are like this. Your statements. So program statements like this. So your program is like this. Okay. So there are some program statements like this. So this is your program. Yes. How interpreter working on this? First interpreter checks the first line. Yes. First interpreter checking first line. See interpreter first of all checking first line. Suppose this line is correct. Suppose for example here, this statement is correct. Yes, immediately it converts into binary code. The statement is correct. Just it converts into binary code. Zeros ones format. And given to processor. So processor taking that binary code, then generating output. That's it. Over. Okay. So interpreter takes the first statement. Yes, maybe Python program, maybe shell script program, maybe HTML. Interpreter based programs. Okay, the scripts here. First statement, first line. Taking first line here, checking syntax. Syntax means some rules. Every language has its own rules. Rules like open bracket, close bracket, open brace, close brace, open double quote, closing double quote, open single quote, closing single. There are some rules. Okay, there are some rules. Every language has some rules here. Nothing but syntax. Okay, so interpreter checking for syntax. If syntax is correct, immediately converts into binary code. After converting into binary code, given to processor generating outputs. One second. See, interpreter checking and converting, right? Yes, sometimes, yes, next statement may be right or wrong. Yes, this next coming statement may be right or wrong. But interpreter never think about next statements. Suppose if this statement is correct, immediately converts into binary codes given to processor generating outputs. Next, after this, checking for next statements. Suppose next statement also correct. Same, immediately converts into binary codes. So immediately just it converts into binary codes. Yes, converts into binary codes. Okay, generating output. Yes, the first statement is correct. First statement is correct, converts into binary code and generating outputs. Checking for second statement, second also correct, converts into binary code, generating outputs. See, interpreter never checking for next statement right or wrong. Next statement may be right or wrong. Never think about it. Just if the statement is correct, immediately converts into binary code, generating output. Next statement also correct, immediately converts into binary code and giving output. Suppose something wrong here, stops. Something wrong here, error comes here, stops. Okay, interpreter shows error in so-and-so line and stops. Okay, so what was happened here? First line checked and output generated. Second line checked, output generated. What was happened here? Line by line checking and line by line generating output, right? So interpreter executes the program line by line. Anyone knows this point here? Anyone will explain like this. Okay, so interpreter, yes, checking first line and giving output. Checking second line, giving output. Something wrong here, stops. If any error comes, interpreter stops. Okay, so interpreter line by line. Interpreter checks and executes program line by line. Interpreter is always line by line. Okay, fine. So this is about interpreter. Same thing. Let us see about compiler here. How compiler is working here? Compiler. Yes, on the same program, how compiler is working here? Yes, let us see about compiler. Yes, compiler. About compiler. Compiler. How compiler is working? About compiler. Source codes. Yes, compiler based program, maybe test.c. C is a compiler based. Test.c program. Test.c. Yes, how it's working here? Yes. Compiler test.c here. Compiler checking first line. If first line is correct, then checking second line. It will check for second line. See, 1 second. First line correct. Even first line correct, it won't convert into binary code immediately. No, never converting here. First statement is correct. Even correct, it won't convert into binary code immediately. It won't execute. It won't convert into binary code. If first statement is correct, checking second statement. Suppose this also correct, then checking next statement. Suppose something wrong here. Error at third line. Error at third line. After that, checking next statement. Correct. Next, go to next statement. Correct. Next, go to next statement. Suppose something wrong here. Error at so-and-so line here. Error at so-and-so line. Okay, like this. Checking next statement. Checking next one and next one. Checking next one here. Suppose something wrong at next line. Showing again error. Error at so-and-so line here. Error at some line here. Error at some line. Error at some line. Okay. So like this, checking all the lines from top to bottom. So compiler checks complete program from top to bottom. Interpreter checks only one line at a time here. Checking line, if it is correct, immediately executes. See, interpreter, how it's working here? Interpreter checking first line, if it is correct, converts, then giving outputs. Second correct, converts and giving output. That is line by line. Any error stops. Any error stops. But compiler is not like that here. Compiler checking first line, if correct, go to second line, correct, go to third line. Suppose something wrong, error. Even error is there. It shows yes, error at third line. After that, checking next line also. Even error comes, it won't stop. Compiler checking from top to bottom. Yes, compiler checking whole program from top to bottom and shows all the errors. Yes, even error getting here, it won't stop here. Even error getting, it won't stop. Checking next statement, next again error, it shows error here. Next statement, again error here, like this. So compiler checking whole program from top to bottom. It checks complete program from top to bottom. Okay. After checking, it shows all the errors. Showing all the errors, right? All the errors, right? Okay. Yes. Now correct all the errors. As a programmer, you have to correct all the errors. As a Java developer or C programmer, you have to correct all the errors. Next time, no error. Everything is fine. This is fine. Okay, next, this also fine. Yes, this also fine. Next time, no error. Everything is fine. If everything is fine, what happens? If everything is fine here, then in that case, it opens another file. If everything is fine, it opens second file here. It opens second file. Okay. If everything is fine, this is your source for test.c. For example, test.c. It's a test.c program. Okay, test.c program. This is your source code, right? Yes, everything is no errors. If no errors, then compile opening another file here. After opening another file here, this whole code converts into binary codes. First statement converts into binary code, writing as binary codes. Okay. Next statements, binary codes. Okay. Next statement, binary codes. Okay. Next statement, binary codes. Next statement, binary codes. That whole program converts into binary code. Whole program converts into binary code at a time here. Whole program converts into binary codes. Okay. Write to this file. That complete code converts into binary code, writing to another file. Writing to another file. Yes. What is this file? Writing to another file. What is this file? This file is called exe file. It's exe. Some test.exe file generates. Test.exe file generates. Test.exe. Exe means executable file. Executable. Yes, executable. So executable file generates. Exe file. So compiler checking whole program from top to bottom. If no errors, then it generates exe file. It generates exe file. Test.exe file. So what is exe file? Exe file contains what? Complete binary code. It's a system understandable language. Okay. So here, after checking complete program top to bottom, if no errors, generating exe file. It generates exe file. Now this exe file given to processor. Given to processor. Given to processor. Now processor taking that exe file and it will run, finally giving output. At a time giving all the output here. Okay. See, complete exe file, whole exe file means complete program submitted to processor, at a time submitted. So at a time giving output, right? So compiler giving output at a time because that exe file submitted. The complete program submitted at a time here. The complete program submitted at a time. So at a time giving output, right? Okay. At a time giving output. But in case of interpreter, what happens here? Line by line. First line converted and submitted. Second line converted, submitted. Third line converting, submitting. But in case of compiler, what happens here? In case of compiler, whole program converts into binary code. Whole program converts into binary codes. After converting it to binary code, that binary file, exe file, submitted to processor. Now processor will execute exe file and generating output. Finally getting output. That's it. Means at a time here. Okay. So this is difference. Let us see one by one points here. What's the difference between interpreter and compiler? So one by one points. Points which we'll discuss here. Difference between interpreter and compiler. Yes, interpreter versus compiler. Yes, interpreter. Yes, interpreter. Next is compiler. Interpreter, compiler. Okay. Yes. So this is minimum. Every software engineer must have this knowledge. What is difference between interpreter and compiler? Yes, without knowing difference between interpreter and compiler, who will work in software field? Yes, any software engineer must have this knowledge, basic. Okay. Yes, interpreter and compiler. What's the difference here? See, let us see first point. First point. Interpreter checks the codes. Interpreter, yes. Interpreter checks. Yes, checks line by line. Line by line. Interpreter checks code line by line. Right? Interpreter checks the code line by line. Checking codes. Checking line by line. Interpreter checks line by line. What is compiler? Whole program. Yes, whole program checking here. Yes, checks whole program. Compiler checks whole program at a time. Whole program at a time here. At a time checking here means all the statements. So at a time here. At a time. So the first difference. Interpreter checks the program line by line, but compiles whole program, checks whole program at a time. At a time. Next, interpreter output. When come to output here, yes, output is line by line. Interpret output is also line by line. Line by line output here. Line by line. Yes, compiler. Yes, output at a time here. Output at a time. At a time. Reason here. Yes, it's executing exe file. Okay. So interpreter at a time, output at a time, as it is executing. Yes, as it is executing whole program at a time here. Whole program at a time here. Not line by line execution here. Whole program. Yes, at a time. At a time, right? Yes. As exe file. Whole program submitted to processor as exe file. Whole program submitting to processor as exe file. So as the exe file executing means at a time giving output here. Output at a time as it's executing whole program at a time. Okay, at a time as the exe file. So this is second difference. Next, third difference. Yes, interpret it shows only one error. Reason, any error comes, it stops. Any error comes, interpreter stops. Interpreter shows only one error. Okay. Yes, compiler. Yes, it shows all the errors. Yes, it shows all the errors, errors from top to bottom. Okay, it shows all the errors. From top to bottom. Fine. Next point, main important point here. Yes, it does not generate exe file. Compiler generates exe file. This is main difference. Okay, 1 second here. Yes, the guy who is having 10 years of experience, 20 years of experience, they don't observe this point here. Simply anyone says that interpret is line by line, compile is whole program at a time. That is common point, common answer. Everyone says that. But actually, what is main difference between interpreter and compiler? Exe file. Exe file is the main difference. Okay. Yes, any interpreter based language don't have exe file. Compiler based language there is exe file. Okay. Suppose C language, compiler based. There is a exe file in C language. C++ exe file, because C, C++, these are compiler based languages. These languages will have exe files. Yes, interpreter based language like HTML is interpreter based language. Next, Python is interpreter based language. Perl scripting is interpreter based language. All the interpreter based languages don't have exe file. Interpreter never generating exe file. Interpreter, it does not generate exe file. Compiler generates exe file. This is main difference. Main difference between interpreter and compiler. You have to present this point compulsory. Yes, once you present it, definitely anyone will attract your answer here. They will satisfy with your answer definitely here. Yes, rare people knows about this. This answer only rare. Who is having good experience in software field, expert in software. Yes, they knows about this one here. So interpreter does not generate exe file, compiler generates exe file. Okay, next point. Yes, if it is interpreter based here, yes, source code executes directly. Source code executes directly here. Yes, source code executes directly. Here. Directly source code executes. Suppose HTML program, directly that HTML program executes here. HTML. Yes, HTML. Open which. See, this is HTML is interpreter based. This code executes directly. No machine language, no binding, no convert. Directly executes here. So HTML directly this code executes. Okay. Suppose Python scripting. Yes, Python. This code executes directly here. Okay, it won't convert into any exe file. This code executes directly. Here. Okay. Yes. If it is interpreter based, source code executes directly. But in case of compiler based here, first generating exe file. That exe file executes. Here exe file executes. Here exe file executes. So interpreter based language, source code executes directly here. Compiler based exe file executes. Yes, interpreter based language examples. Yes, all scripting languages are interpreter based language here. Interpreter based languages. Okay, example HTML, HTML, yes, HTML, Python, yes, HTML, Python, Perl scripting, yes, next PHP programming, next Linux shell scripting here, next Linux shell here, Linux, yes, Linux shell scripting here, next JavaScript. These are interpreter based language here. Linux shell, JavaScript, all these are interpreter based language. Okay, next compiler. These all programming language, all programming language here, all programming languages. Okay, all programming languages comes in this category. All programming languages, all programming languages. Yes, example, programming language like C, yes, C++, yes, .NET, yes, .NET, C hash comes under this compiler based here. Okay, what is Java? We'll discuss. Okay, yes, Java is not a purely interpreter based, purely compiler based here. Java depending on both. Java is interpreter as well as compiler both. That point we'll discuss next. Okay, Java is not a purely compiler based, not a purely interpreter based, depending on both here. These are purely interpreter based language. All scripting languages are interpreter based language. All programming languages are compiler based. But Java depending on both here. Java is both interpreter as well as compiler. That point we'll discuss. Wait. I'll explain that point also. Yes. So this is difference between these two here. So interpreter checking line by line. Yes, compile checks from top to bottom, whole program from top to bottom here. Interpreter output line by line, but compile based output at a time because of exe file. As a single file submitting, as at a time submitting here. That exe submitting at a time as exe. All these statements submitting as exe means at a time executing. Okay. Next, it shows only one error. Yes, it shows all the errors. Compile all the errors. Next, it does not generate exe file. Compiler generates exe file. Okay, this is main difference. What is main difference between interpreter and compiler? Yeah, that point exe file that we should discuss. Okay, if we know the exe file, then easy to understand Java independent of platform. Yes, to understand this point here, independent of platform. To understand that point here. Okay, yes. To understand that point only, I'm explaining all these things here. Yes, independent of platform. To understand that point here, I'm explaining this topic here. Otherwise, not required here. Okay. Yes. What is exe file? We'll discuss now. Wait. Next, source code executes directly here. Exe file. Next, interpreter language and compiler based language. Okay. Now, one point. Remember one point here. Main point. Yes, any language, yes, maybe scripting language, maybe programming language, maybe scripting, maybe programming language, any language which is runtime is an interpreter based, no exe file concept. Right, remember this point here. Okay, so any language which is runtime is interpreter based. Any language which is runtime is interpreter based. Any language which is runtime is interpreter based. No exe file concept here. Any language, okay, yes, any language which is interpreter based at runtime, any language which is interpreter based at runtime, no exe file concepts. Okay, no exe file concept here. Okay, so any language which is interpreter based at runtime, no exe file concepts. For example, HTML, Python, Perl, PHP, Linux, JavaScript. These are interpreter based languages. For this, no exe file concepts. No exe file concepts. Try to remember this point here. This point. Next point here. Next point. See, any program has to communicate with hardware through the OS library. Compulsory OS library required here. So every program, next one more point, second point here, every program. Okay. Yes, every program, every program, yes, every program communicates, every program communicates with hardware, yes, through the OS library. One more point, through the OS library, right? Through the OS library. These 2 points. Once again, try to remember these 2 points here. Okay. So any language which is interpreter based at runtime, no exe file concepts. Okay. For this programming language, for the scripting language, no exe file. HTML, no exe file. Python, no exe file. Perl scripting, no exe file. For these languages, no exe file. Next, every program, maybe, yes, maybe script or maybe language, maybe program. Okay, every program, maybe HTML program, Python program, C program, C++ Java program. Every program communicates with hardware through the OS library. Yes, try to remember these points here. Okay, fine. Now question is, what is exe file? What is this question? What is exe file? See, 1 second. Yes, independent of platform. For this, what is platform? Okay, how Java made us independent platform? That to understand that here, what is interpreter, what is compare next, what is exe file? Yes, these 2 points completed. These 2 discussed. Once this is completed here, now we can understand independent platform. Okay, now let us see what is exe file. Yes, now question is, what is exe file? Question is, what is exe file? Okay, so exe file, generally anyone says that yes, exe file is a system understandable code. Exe file is a, yes, exe file, anyone says that exe file is a system understandable code. Generally anyone says that. Yes, I'll agree with that point here, no doubt. I'll agree. Yes, exe file is a system understandable code, means in binary format. Yes, it is in binary format. 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 Okay, it is in binary format. Yes, anyone says that here. It is in binary format. Exactly what is exe file? Exactly what is exe file? Exe file. What does it contain here? What does it contain here? What does it contain? What does it contain? That point we should discuss. What does it contain? Yes, let us take C program exe file. C program file exe file. See, after compiling C program exe file. Yes, after compiling your program here. Yes, after compiling program, if it is fine, yes, it generates exe file. How it generates exe file? It generates exe file here. How it generates? Yes, here after compilation here, after compilation, yes, after compilation, yes, after compilation, yes, after compilation here, after compilation, yes, if no errors, if no errors, if no errors, if no errors, then linker starts working. Linker is a part of compiler. The linker links binary code of C program, comma, next binary code of C library, comma, binary code of OS library, and hardware information, and hardware information, yes, information like 30 bits or 64 bit, that information, 30 bits or 64 bits, and generates exe file, exe file, generates exe file. Okay, yes, what is library? I will explain. Okay, So what is exe file here? Exe file contains what? For example here, for example, for example, for example, for example, exe file created on Windows OS. Okay. For example here, for example, yes, C program, yes, exe file. For example, yes, C program exe file created on Windows OS. Then exe file contains first one, binaries of C program, binaries of C program plus, yes, C library binaries of C library. C library means like stdio.h, string.h. There are some library files. Library files including the word program, right? Has include stdio.h. Okay. So first binaries of your C program here. Okay, right? Next binaries of C library plus binaries of, yes, binaries of Windows OS library. Yes, library is a collection of input output functions. Okay. So Windows library plus next hardware information. Binaries of Windows library plus hardware information This is complete exe file. Okay, right? Suppose exe file prepared Windows OS, that exe file linked with Windows library. Okay, if exe file prepared on Windows OS, it contains Windows library. Okay, Windows library. Yes, it contains Windows library. Yes, what is purpose of that library here? Yes, at runtime exe file, yes, exe file communicates with hardware yes, through the OS library which is linked with exe file. Okay, yes, see, suppose if exe file prepared Windows first, it contains Windows library. Means Windows library already linked. Yes, exe file linked with Windows library here. At runtime, exe file communicates with hardware through the OS library. Means that Windows library. Okay. So at runtime here, exe file communicates with hardware through the OS library, which is linked with exe file here. Okay, right? Yes. So C program exe file linked with OS library. Since linked with OS library, directly communicates with the hardware components using that library here. See, for example, here test.exe file. For example, test.exe file. Okay, test.exe file is generated on Windows. For example, here on Windows. Then it contains what? Windows library. It contains Windows library. Right? It contains Windows library. Fine. Test.exe file generated on Windows OS, then it contains Windows library. Okay, fine. Now test.exe file linked with Windows library. Okay. See, first beginning we have discussed one point here. See, any program communicates with hardware through the OS library. A C program linked with OS library then communicates. Yes, even every program links with OS library then communicates the hardware. See, in case of C language, exe file. In case of exe file, at the time of creating exe file itself, that OS library links to exe file. Using that library, it communicates with hardware components. Now, let us see that how it's communicating here. Yes, let us take OS. Yes, suppose hardware. This is, for example, here it's a hardware. Hardware. Here it's a hardware. Sorry, hardware. 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 Yes, on top of hardware, there is a Windows base. Windows base. Windows. Windows base with library. Windows base with library. Right, okay. Yes, next. Suppose next test.exe. Test.exe file. Okay. Now test.exe file generate on Windows base, it contains Windows library. Now test.file linked with Windows library. Now at runtime, once you submitted test.exe file, now this test.exe file already linked with OS library, already linked, means static link. At compile time itself, at the time of creation of exe file itself, that library already linked. Once library linked here, yes, at runtime, now the test.exe file, it will try to invoke Windows library on this OS here. Yes, it's available. It's available. Test.exe file contains Windows library. That exe file contains Windows library. That exe file it tried to call Windows library. Yes, available. Same environment available here. Using that Windows library, then communicates with hardware components. Fine, well and good. Suppose same thing. Let us take another platform here. Yes, another one. Yes. Yes, in place of Windows, let us take another one here. Yes, let us take Linux base. Linux base with Linux library. Now test.exe file contains Windows library. Now this test.exe file, it will try to call Windows library on these environments. See test.exe file linked with Windows library, it will try to call Windows on the Windows environments. Now it's a Linux environment. Same exe file placed on Linux base here. Okay, try to execute, try to run, what happens here. Now this .exe file try to invoke Windows library, it will try to call, yes, it's try to call Win library here. It will try to call Win library here. Yes, it will try to invoke Windows library. It will try to invoke Windows library on Linux base, but not able, fails. It fails. So exe file is OS dependent. Yes, exe file is OS dependent here. Okay, reason it contains OS library. Okay. Yes, exe file always OS dependent. Exe file. Yes, exe file is an OS dependent. Is an OS dependent. OS dependent. Reason. Yes, exe file is an OS dependent. Reason. Yes, reason. Yes, it is linked with. It is linked with. It is linked with OS library. OS library. That's it. Yes. Since it contains yes OS library, yes, it's a OS dependent. Exe file is an OS dependent here. Reason it is linked with OS library. Suppose exe file prepared on Windows OS, it will run on only Windows OS. It won't work with other operating systems. Suppose exe file prepared on Linux OS, it will run on only Linux OS. Reason that exe file linked with Linux library. It won't work on other operating systems. Suppose exe file prepared on Unix OS, that Unix library linked with exe file. So it's a OS dependent here. Okay. Yes, here exe file is always OS dependent. OS dependent reason it contains OS library. Exe file contains OS library. Since exe file linked with OS library, it's a OS dependent. Okay. Yes, here since question is yes, see simple answer is since exe file yes is linked with OS library. OS library is it's a OS dependent. It's a OS dependent. That's the reason. Okay. So this point is clear, right? OS dependent. So exe file is a OS dependent. Reason it contains OS library. Now come to Java. Java is independent of platform. How? Java, yes, is an independent of platform. Independent. Yes, how Java made us independent of Java is an independent of platform. Platform. Yes, how Java made us independent of that question here. How Java made us independent of platform? That question here. Okay. See, exe file is a OS dependent, but Java is independent of platform. Independent of platform. Exe file is a platform dependent. Exe file is a platform dependent, but Java is independent of platform. Reason here, Java everything is dot class file. Okay, Java it's a dot. Yes, see Java no exe file concepts. Yes, in Java no exe file concepts. No exe file concept in Java here. No exe file concept in Java. Okay, no exe file concept in Java. Yes, maybe this is a question here. Can we create exe file in Java? No. Yes, the topic also we'll discuss next. Can you create exe file in Java? No, no chance. Maybe asking this question also interview question. Can we create exe file in Java? No, we can't create. See, what are topics I'm explaining, everything prepared in documents. I have prepared in document, don't worry. Every point is there, nothing missing, every point is there. Yes, in Java, no exe file concepts. In Java, no exe file concept here. Yes, everything is dot class file. Everything is a dot class file. Dot class file. Everything is a dot class file. So what is dot class? Now question is what is dot class file? What is dot class file? What is dot class file? What is dot class file here? So what is dot class file? See, dot class. After compiling, generating dot class file, the dot class file contains what here? Dot class file contains Java code plus Java library. Java library. That's it. Java library. Java library. Java code plus Java library. No OS library. No OS library here. Purely Java code. Java code and Java library contains Java code and Java library only here. Yes. Dot class file does not contain any OS library. Dot class file. See dot class file. Dot class file. Dot class file don't have any OS library. Any OS library. Yes, any OS library. Dot class file don't have any OS library. No OS library linked with dot class file. No OS library linked with dot class file here. Purely Java codes. Purely Java codes. Yes, dot class file is a purely Java code. No OS library linked to dot class file. Now question is how it executes. Yes, any program. Yes, any program communicates with the hardware through the OS library. Library required compulsory. Suppose if it is C program, at the time of generating exe file itself linked with OS library, then using OS library. Already linked. OS library already linked. Okay, using that library, it will communicate. It communicates, right? Okay. Yes, now that is the question. Yes, dot class file don't have any OS library. Then how it can communicate with output devices, hardware components? That is the question. Okay. Dot class file don't have any OS library. Without having OS library, how dot class file can communicate with output devices, hardware components or OS here? That is question. Okay. Yes. Now let us come to point here. Suppose tested dot class file created. Tested dot class file created on Windows OS. On Windows OS. Windows OS. Okay. Even created on Windows OS, it contains only Java codes. Okay, only Java codes. Yes, in byte formats. Only Java code in byte formats. Means dot class file. Okay, dot class file. Yes, even it contains only Java codes. No OS library. Okay, no OS library. Even it don't have any Windows library here. Tested dot class file created on Windows OS here. It contains only Java codes. No OS library. No OS library. No OS library, right? No OS library. Then how it works. Now let us come to point here. Same thing. Let us apply for Java. Same environment. Let us apply for Java. Okay. Now test dot class file. Test dot class file. Right. Test dot class file. 1 second. Test dot class file. No test dot class file. Test dot class file. No test dot class file is not a prepared file. Exe file is already prepared file. Exe file is prepared file for specific OS. Suppose exe file prepared on Windows OS, it works on only Windows OS. Already prepared file. Exe file is already prepared file here. Yes, it will run on specific operations. But dot class file is not a prepared file. Dot class only Java program, purely Java program. It's not a prepared file. Okay, correct? Now this dot class file is running on Windows OS. This dot class was submitting to Windows OS. Now this dot class file has to link with Windows library. We will link it. Yes, a dot class file don't have any OS library. Dot class don't have any OS library. The dot class file has to link with Windows library. We will link it here. For this is a yes JVM. Yes, now JVM will come to picture. Okay. Now JVM takes the dot class file. JVM just taking dot class file here. After taking dot class file here, it links to Windows library. So tested dot class file is not a prepared file. At runtime here, before running dot class file here, simply links to OS library of linking, then running, generating outputs. Means a dynamically linking here. At runtime linking here. Suppose C program exe file. If it is exe file, in case of exe file, at the time of creating exe file itself, that link takes place. At the time of creation of exe file itself, OS library links to exe file, means static link. A C program exe file is statically linking here. At the time of creation of exe file itself, linking, that is static linking. Okay, at the time of creating exe file itself, linking OS library, that is called static link. Yes, all exe files is static link. Exe files are already prepared files, need not prepare separately, already prepared files. But when come to Java here, Java dot class file is not a prepared file. Yes, it does not contain any OS library, no OS library. It's not a prepared file. See this dot class file, first of all moving to Windows OS. After moving to Windows OS, this dot class file first of all moving to Windows OS. After moving to Windows OS here there is a JVM. Windows JVM taking our dot class file and link it to Windows library. Once link established, then executes and finally giving output. So output simply, yes, output goes to hardware. Yeah, that's it here. So it's a dynamic linking here. So Java program links at runtime. Java program links to OS runtime here. It's a dynamically linking here. Java program linking dynamically. Who will link it here? JVM. Next Linux. Same test.class file. Same dot class file as this move to Linux OS. Okay. Now Linux JVM taking yes dot class file links to Linux library. Once linked here, communicates with output device. Okay. Same thing with Unix OS. Unix library. Yes, Unix library. Now this dot class file. Simply this dot class file here. This dot class file. Yes, move to Unix OS. On Unix OS, this is JVM. That JVM links to Unix library. Once linked to Unix library, communicates with hardware components. That's it here. Now JVM is responsible to link your dot class file to that OS library. Okay. So once link established to OS library, then communicates and generating outputs. So what is happening here? It's a dynamically linking. Yes, in Java dot class file is not a prepared file. After moving on to OS, as per current library, JVM links. Once link established, then executes and giving output here. So Windows JVM linking test.class to Windows library. Next Linux JVM linking test.class file to Linux OS here. Next Unix JVM linking your test.class file to Unix library. Once linked here, then executes and giving outputs. Means only one time we are creating test.class file is creating a same test.class file is executed on every OS, right? Because of JVM. Because of JVM. Now here dot class file is independent of OS, independent of platform, but JVM is OS dependent. JVM is OS dependent. This JVM for Windows, this JVM for Linux, this JVM for Unix OS. JVM is a OS dependent. Okay, JVM is a exe file developed in C++. JVM was written in C++. JVM is a C++ exe file. JVM is a C++ exe. So JVM is a exe file and its OS dependence. Yes, this is Windows JVM. This is Linux JVM. This is Unix JVM. Right? Okay. See here, your Java program. Java program is independent of platform. Java program is independent of platform. Java program is independent of platform. But JVM is platform dependent. Suppose here, question is here. Windows, does it connect JVM, built-in JVM? No. No built-in JVM to OS here. Yes, maybe somebody doubt. Windows is having its own JVM, Linux is having its own JVM, Unix having its own JVM. No. Operating system don't have any JVM. You have to install it. You have to install. Yes, you have to install it here. For Windows OS, you have to download JDK for Windows and install it here. Next, download JDK for Linux, install it here. JDK for Unix, install it here. Different JDKs you have to download, you have to install it here. Once JDK installed here, JVM generating. JDK for Windows installed, Windows JVM generating here. JDK for Linux installed here, Linux JVM generating here. So JDK differing from OS to OS. So JDK differing from OS to OS. JDK differing from OS to OS because JVM is OS dependent. Okay, so Windows JVM is having knowledge of Windows library. Linux JVM is having knowledge of Linux library. Unix JVM is having knowledge of Unix library. With that knowledge, it communicates. Yeah, this is reason behind of this. How Java made us independent of platform? Simple reason is this. Okay, JVM is responsible. Okay, yes, to understand this point here, yes, explain about exe file, explain about interpreter, compiler. If you know that all the prerequisite, you can understand this point here. Generally, most of the trainers directly they will explain independent of platform is independent of OS. Developing on one OS and running on any OS. Anyone says that. But my way is not like this. Internals, including internals. How it is independent of platform? Yes, I'm sure it's my challenge. No trainer will explain this kind of way because my experience is like this. Not only trainer. Yes, even no website in the world will explain like this. My experience is more than industry. It's my challenge. Yes, try to bring bring to notice. Okay. Yes, visit any site. No one how Java made us independent platform. This kind of explain nobody will explain here. Okay, to explain this, yes, exe file knowledge required, OS knowledge required. Yes, the guy who is having OS internals knowledge. Next, how exe file is creating that knowledge, who is having that knowledge, they can explain this one here. Okay, I know how JVM was written. JVM was developed in C++. Even I know that code, JVM codes, how JVM made the Java as independent platform here. Behind this C++ code is running here. So when you submitting Java program, JVM working. Yes, behind of JVM C++ code is work. Even that code also I can explain how that code is working. C++, how that C++ code is working. Even that also I can explain, but may not be understanding. That much of depth is not required for us. Okay, yes, enough up to this. Right, okay. Yes, you understand everyone? Is it clear? So generally here my topics, yes, little bit difficult to understand because I'll be going in depth. Okay. Yes, little bit going in depth. Try to understand slowly. If you understand slowly here, then yes, yes, you'll be having bright future. Because when you put up the experience for 4 years, then you should explain these kind of things. Okay. As a fresher, maybe this much of knowledge may not be required here, but as a 4 years experience applying for jobs, you must explain this. Okay, right? Yes. See, I'm sure it's my challenge. Nobody will explain this much of depth. Okay. Yes, you attend various trainers. Okay. Who are saying that, yes, we are number one in Java. Yes, we are number one faculty in India. Like that, many trainers says that, but they don't know about these fundamentals also. Okay. They don't know what is exe file. They will not, they can't explain exe file. Yes, to explain about exe file, the trainer must have exe file knowledge first of all, means embedded C. You who work in embedded C, they can explain about exe file, they can have explain OS internals. Without embedded C experience, no one can understand. Yes, even sorry, no one can explain here. Yes, here because of that embedded C knowledge, I'm able to explain this. Is actually my career started with embedded C, later changed to Java career. Okay. Yes, sir. So this is about this. One second. Yes, I'll save this one. Tomorrow I'll continue this one here. This topic will continue here. Tomorrow topic. Yes, independent platform completed. Independent platform complete here. In this, what is platform? What is mean? What is platform? What is interpreter? What is compiler? What is exe file? Interpreter versus compiler here. Finally, how Java measures independent platform. Finally, like this. Yet, so step by step explain very clearly, right? Okay. So next is portability. How Java is a portable. Tomorrow we'll continue. Okay. Yeah, tomorrow. Yes, I'll finish by 9:30 only here. Today extended some 15 minutes extended here. Tomorrow I'll finish at 9:30. Reason here, some topics we can't break it. Some topics cannot be break. We can't break some topics here. That's the reason 15 minutes extended. Okay. Tomorrow, yes, we'll go for next one. What is next one here? Next one, independent platform complete here. Next, portability. Oops, yes. Tomorrow these features will be finishing. Okay. Yeah. So that's all. Okay. One minute. 1 minute. Till now, what are we discussed? It's there in document here. In document here, introduction to software, system software, application software. Next, yes, see here, applications of front end, back end. Yes, language packages. Next, languages, low level languages, high level languages. Next, generation of languages. Next, interpreter compile the differences. Very clear explain document here. Okay. Yes, Java depends on both interpreter and compiler. The topic tomorrow we'll discuss. Tomorrow we'll discuss about this. Every point is there in the documents. Yes, tomorrow taking class. Tomorrow I'll be finishing these features. Tomorrow I'll be finishing features. Okay. Tomorrow just 1 hour class I'll take it and I'll close it. Okay, right? Yeah, that's all. Tomorrow don't want session. Tomorrow you want holiday. Hello. Yes, no holiday will continue. Yes, it's an online class. If it is all offline, you have to come to institution and lot of time taken and all this, right? Holiday not necessary. Just only 1 hour class I'll take it here. 9 to 10:30 I'll take it. 8 to 9, 8 to 9. Only 1 hour class I'll take it. Tomorrow only 1 hour class. 1 hour 15 minutes. 8 to 9:15 I'll finish. Right? Yes. Thank you. Yes. See you tomorrow. Yes, thank you everyone. See you tomorrow.